Welcome to Matic, where we help people fear less, build confidence, solve problems, all by explaining fundamental principles of calculation so you don't feel awkward or scared whenever you need to deal with any number or numerical task. Today, we will focus on multiplication using visual drawings. It will be simple, it will be effective. All you need is a piece of paper and pens, 3 colors. Once you learn the technique, you will multiply faster than a pro. Firstly, let's define the structure of each number. Let's take number 213 as an example. The number consists of 3 digits, 2, 1, and 3, and each digit has its specific position. Number 2 is at the position of hundreds. Number 1 is at the position of tens, and number 3 is at the position of ones. In other words, we can write number 213 as 2 times 100, 1 times 10, and 3 times 1. Why is this important? Because of our drawings. For each of the positions, we will define specific color. Let's use blue color for hundreds. Let's use pink color for tens, and let's use green color for ones. We will use lines of appropriate colors to visually draw the numbers. Moreover, as we will multiply, the lines will cross. The result of the multiplication will be the number of intersections of the lines, counted in systematic way. Confusing? Let's try explain the method of the example of multiplication of 13 times 22. Number 13 consists of 1 10 and 3 ones. We will draw one line in pink and 3 lines in green, all of them vertically. Number 22 consists of 2 tens and 2 ones. We will draw 2 lines in pink and 2 lines in green, both horizontally. We will draw 2 supporting lines that will help us by visually separating ones, tens, and hundreds. By counting number of intersections in each separated area, we will get the multiplication result. Let's start counting from the right bottom corner to the left. There are 6 intersections of green lines, so we have number 6 at the position of ones in the final result. There are 8 intersections of green and pink lines, so we have number 8 at the position of tens. And finally, there are 2 intersections of pink lines, so we have number 2 at the position of hundreds in the final result. To sum up, 13 times 22 is 286. What about 22 times 31? Let's start with drawing of number 22. There are 2 pink lines at the position of tens and 2 green lines at the position of ones, all drawn vertically. Number 31 consists of 3 pink lines at the position of tens and 1 green line at the position of ones, all drawn horizontally. We will draw 2 separating lines that will help us by visually separating ones, tens, and hundreds. Again, by counting the intersections in each separated area, we will get the multiplication result. Let's start counting from the right bottom corner to the left. There are 2 intersections of green lines, so we have number 2 at the position of ones in the final result. There are 8 intersections of green and pink lines, so we have number 8 at the position of tens in the final result. And finally, there are 6 intersections of pink lines, so we have number 6 at the position of hundreds. To sum up, 22 times 31 is 682. Now let's try a bit more difficult example of multiplication 34 times 15. Let's draw number 34. There are 3 pink lines at the position of tens and 4 green lines at the position of ones, all drawn vertically. Number 15 consists of 1 pink line at the position of tens and 5 green lines at the position of ones, all drawn horizontally. 2 supporting lines will separate ones, tens, and hundreds. Let's start counting from right bottom corner to the left. There are 20 intersections of green lines. So now what? Given we are searching for the last digit, we will write number 0 as the last digit in the final result, keeping in mind number 2. There are 19 intersections of pink and green lines. We will add number 2 from previous step to get number 21. Again, we can write only one digit, so we will write number 1 as the second last digit in the final result, keeping 2 in our minds. There are 3 intersections of pink lines. We add number 2 from previous step to get number 5, the first digit in the final result. To sum up, 34 times 15 is 510. What about 42 times 35? We will start drawing number 42. There are 4 pink lines at the position of tens and 2 green lines at the position of ones, all drawn vertically. Number 35 consists of 3 pink lines at the position of tens and 5 green lines at the positions of ones, all drawn horizontally. 2 supporting lines will separate ones, tens, and hundreds. So let's start again counting from the right bottom corner to the left. There are 10 intersections of green lines. Given we are searching for one digit, we will write 0 as the last digit in the final result, keeping in mind number 1. There are 26 intersections of pink and green lines. We will add 1 from previous step to get number 27. Again, we can write only one number, so we will write number 7 as the second last digit in the final result, keeping in mind number 2. There are 12 intersections of pink lines. We add number 2 from previous step to get to number 14. So first 2 digit in the final result will be 14. To sum up, 42 times 35 is 1470. What about 50 times 23? We will start drawing number 50. There are 5 pink lines at the position of tens and 0 green lines at the position of ones. So we will not draw any green lines for number 50. Number 23 consists of 2 pink lines at the position of tens and 3 green lines at the position of ones. 2 supporting lines will separate ones, tens, and hundreds. Let's start counting from the right bottom corner to the left. There are 0 intersections of green lines. So last digit of the final result is 0. There are 15 intersections of pink and green lines. As we can write only one digit, we write number 5 as the second last digit in the final result, while we keep in mind number 1. There are 10 intersections of pink lines. We add number 1 from previous step to get to 11, first 2 digits of the final result. To sum up, 50 times 23 is 1150. Let's increase the level of difficulty. Let's try to multiply 3-digit numbers. The system that we will use will be the same as in multiplication of 2-digit numbers. Only difference being the blue lines representing hundreds. 123 times 211. Number 123 consists of 100, 2 tens, and 3 ones. We will draw 1 blue line, 2 lines in pink, and 3 lines in green, all of them vertically. Number 211 consists of 2 hundreds, 1 tens, and 1 ones. We will draw 2 blue lines, 1 pink line, and 1 green line, all of them horizontally. We will draw 4 supporting lines that will help us by visually separating ones, tens, hundreds, thousands, and tens of thousands. By counting the number of intersections in each separated area, we will get the multiplication result. Let's start counting from the right bottom corner to the left. There are 3 intersections of green lines, so we have number 3 at the position of ones in the final result. There are 5 intersections of green and pink lines, so we have number 5 at the position of tens. There are 9 intersections of blue and green, and pink lines, so we will have number 9 at the position of hundreds in the final result. There are 5 intersections of blue and pink lines, so we have number 5 at the position of thousands, and there are 2 intersections of blue lines, so we will have number 2 at the position of tens of thousands. To sum up, 123 times 211 equals 25,953. 235 times 312. Number 235 consists of 2 hundreds, 3 tens, and 5 ones. We will draw 2 blue lines, 3 lines in pink, and 5 lines in green, all of them vertically. Number 312 consists of 3 hundreds, 1 ten, and 2 ones. We will draw 3 blue lines, 1 pink line, and 2 green lines, all of them horizontally. We will draw 4 supporting lines that will help us by visually separating ones, tens, hundreds, thousands, and tens of thousands. By counting the number of intersections in each separated area, we will get the multiplication result. Let's start counting from right bottom corner to the left. There are 10 intersections of green lines. We are searching for the last digit, so we will write number 0 as the last digit in the final result, keeping number 1 in our minds. There are 11 intersections of green and pink lines. We will add number 1 from previous step to get 12. Again, we only need one digit as our second last digit in final result, so we will write number 2, keeping in mind 1. There are 22 intersections of blue and green and pink lines. We add number 1 from previous step to get to 23. We write 3 at the third last position of our final result, keeping in mind number 2. There are 11 intersections of blue and pink lines. We will add number 2 from previous step to get to 13. We write number 3 as the next digit in our final result, keeping in mind number 1. There are 6 intersections of blue lines. We will add number 1 from previous step to get to 7, the last digit of the final result. To sum up, 235 times 312 equals 73,320. Nicely done, good job, like. But let's be honest, there is one step in the process where I personally do struggle. How to draw these lines that separate ones, tens, hundreds, and thousands. What if we are multiplying 3-digit number by 2-digit number? Then we might get confused. Let's try to explain at the simple example of 102 times 30. Before we draw the lines, it's helpful to realize that we are multiplying numbers with expected result to be 4-digit number, while at the same time we are multiplying twice with 0, so there must be 2 zeros in the final result. Once we draw the lines, it is obvious that there are no intersections in ones, there are 6 intersections in tens, 0 intersections in hundreds, and 3 intersections at thousands. So final result is 3060. Let's try one more difficult example of multiplication of 750 times 43. Once we draw the supporting lines, we realize that there are no green lines for number 750. Last digit of the final result will be therefore 0. Next, at the 10th digit, total number of intersections is 15. So we write 5 as the second last digit in the final result, keeping in mind number 1. At hundreds, there are 41 intersections. We will add 1 from previous step to get to 42. So we write number 2 in the final result, keeping in mind number 4. In the last step, there are 28 intersections. So we will add number 4 from previous step to get to 32, last 2 digits in the final result. So final result is 32,250. Let's sum up what we have learned today. We use lines of different colors to visually draw the multipliers. Then we draw supporting lines that visually separated ones, tens, hundreds, thousands, and tens of thousands in the final result. Finally, we counted the number of intersections in each separated areas, getting the final result from the last digit to the first one. What do you think about this approach to multiplication? Please let me know in your comments. With that, thanks for watching, and please subscribe to our channel to get the latest training materials and information about our online courses.